Okay, this lesson, pretty simple and straightforward, and you've seen a lot of this before, which is nice, so it makes it a little bit easier. We're starting with line symmetry, which you've seen since elementary school, and the way you saw it in elementary school is you were given maybe like a heart, and you were told to like draw a line of symmetry, and you would draw a line like this, which means like both sides of the heart are reflected the same on both sides, and this is your line of symmetry. So that's what line symmetry is. This lesson has a little bit more than that, but that's where we're starting. So for the first set of problems, it says state whether the figure appears to have line symmetry, write yes or no. If so, draw all the lines of symmetry and state their number, like how many lines of symmetry there are. So for the first one, like one of the lines of symmetry would be right here, and it makes it so it's a reflection on both sides. So yes, it has line symmetry. And then it just wants to know how many it has. Well, we have one line of symmetry here. You could also draw a line of symmetry here, and it's reflected the same on both sides. And then you could also have a line of symmetry here, and it's reflected on both sides. So this shape has 3 lines of symmetry. And if you have a regular shape, meaning all the sides are the same, like a triangle, a square, a pentagon, that kind of thing, the lines of symmetry is the same as the number of sides, so that can help you out as well. Like a regular octagon would have 8 lines of symmetry. For number 2, it wants to know whether it has line symmetry. I maybe try to draw a line of symmetry right here, and then you'll realize that it's actually not reflected the same on both sides. Like this sticks out here, so it should stick out over here, and it doesn't. Or if I try to draw a line of symmetry right here and reflect it, like this should be sticking out, and it's not sticking out there. So this one is a no to line symmetry, no line symmetry. Number 3, first thing we need to answer is whether it has line symmetry. If I draw a line right here, obviously it's not the same reflected on both sides. If I draw a line here, it looks like it might. However, if you look closely, this is a 90-degree angle and this is not. So it's not the same thing reflected on both sides. So no line symmetry here. Then for number 4, this one works out where you can draw a line here. It's reflected the same on both sides. So yes, it does have line symmetry. And then we could also draw a line of symmetry right here, and it's reflected the same on both sides. So this has 2 lines of symmetry. Okay, so while we're on the same skill, we're going to go over here and I'm going to have you try. So you try it. You're going to answer whether it has line symmetry, yes or no, and then how many lines of symmetry, and also draw them as well. So you're answering whether this has line symmetry, yes or no, and how many lines of symmetry does it have. I'm going to freeze this here, and then I'm going to answer it too, and we can compare. Here is what I got. Okay, so here's my answer so you can compare. 1, I can draw a line like this and it's reflected the same on both sides, so yes, and it has 1 line of symmetry. This one, I could draw a line here and then also a line here and it's reflected on both sides, so there has 2. And then this one, no matter how I draw a line, it's not going to reflect the same on both sides, so this one is no line symmetry. And over on this side, now we're going to look at rotational symmetry. This is new. It did come up in one of the lessons before, but it's new to the curriculum this year. Rotational symmetry is when you can rotate a shape onto itself before turning it 360 degrees all the way around. So it says state whether the figure has rotational symmetry, write yes or no. If so, locate the center of symmetry and state the order and magnitude. Okay, so what I did right here was I made a dot right here. This is going to be the center of rotation. And I want to know that I can rotate this onto itself before I rotate it all the way around 360 degrees. And yes, I can rotate this. Yes to rotational symmetry. Like one turn like this would land it right on it to itself. The order is how many times it would land on itself in a 360 degree rotation. So to find the order, you can just count the spikes, like 1, 2, 3. It would land on itself 3 times. And then magnitude of rotation is how many degrees you would turn it for it to land on itself. So you could take 360 degrees divided by 3, comes out to 120 degrees. So every 120 degrees, it would land on itself again. Okay, and this one right here, number 6, the center of rotation would be right here. Does it have rotational symmetry? Yes, it looks like I can rotate it like one little turn and it'll land on itself again. So yes to rotational symmetry. I need to identify the order and the magnitude. Okay, so the order is how many times it would land on itself. So it's like how many spikes it has. 1, 2, 3, 4, 5, 6, 7, 8. And then the magnitude is just 360 divided by 8 equals 45 degrees. Yeah. Oh, yes, you can. And then just use the video to finish. Okay, then number 7, the center of rotation would be right here. Does it have rotational symmetry? Well, it looks like I could rotate it 180 degrees, which isn't like 360, so we're good. So yes, it does have rotational symmetry. The order, this would land on itself 2 times. And then magnitude, 360 divided by 2 is 180 degrees. So every 180 degrees, it would land on itself. Guys, have a great day. You too. Have a good one. See you tomorrow. Okay, number 8, put the center of rotation right here, maybe. Would it rotate on itself before it goes all the way around? No, it wouldn't. So this has no rotational symmetry. Done, we'll move to the next. So we'll practice it over here. So you're going to try it on your own, just yes or no, whether it has rotational symmetry or not. What is the order and magnitude? So yes or no, order, magnitude, yes or no, order, magnitude. Okay, I'm going to freeze it and fill in as much as you can. With the magnitude, I realize you don't have, might not have calculators, so just like write out the equation and we'll fill in the numbers. Also identify the center of rotation too. 360 divided by 5 is 72 degrees. Here's what I got for answers. For number 4, yes, I could rotate it like 180 degrees for it to land on itself. It has two orders, or like two places it would land on itself. The magnitude would be 360 divided by 2, which is 180 degrees. This one, yes, put the center of rotation right here. The order, there's 5 places it would land on itself. So 360 divided by 5 is 72 degrees. So every 72 degrees, it would land on itself. This one, you just had to make sure to count correctly. There are 16 spikes that go all the way around, so the order is 16. And then 360 divided by 16 is 22.5. Okay, next, over here. Okay, so these two are new as well. Plane symmetry and axis symmetry. What plane symmetry is can you slice this with a plane and have it be the same like shape, 3D shape on both sides? So if I was to slice it right here with a plane, like imagine it being sliced, would it be the same on both sides? And it would be yes. You could slice this right down the middle and it's the same exact like volume and shape and everything on both sides. Same with the cone. Like I could slice it right down the middle of the cone with a plane and it would be the same exact on both sides. So yes. Then axis symmetry, what that means is that you have like a pole down the center like this. Can you rotate it around that pole and have it land on itself before going all the way around? So in this case, you could rotate it 90 degrees and it would land on itself. So yes, to axis symmetry. And then for the cone, same thing. You could rotate it around this pole and it would land on itself before it got all the way around. So yes, actually it would always be on its. And then over on this side, we're going to do the same thing. Plane symmetry and axis symmetry. Plane symmetry, axis symmetry, plane symmetry, axis symmetry. Okay, so for number 7, could you slice this with a plane and it's the same on both sides? Yes, you could. You could slice it this way, like, and then you could also slice it this way and it would be the same on both sides. So yes to plane symmetry. For number 8 with plane symmetry, the first way I thought we would do this is like this way, which seemed logical to me. However, when you slice it this way, this is like a 90-degree angle, this is not, so it's not the same on both sides. So the way you can slice to get plane symmetry is actually this way, and then it would be the same on both sides. So you'd slice it here, and then it's the same on both sides, so yes to plane symmetry. It's like you can slice it vertically like that. Yes.
Could we slice the X like down the middle the other way?
You could, yeah, like this way too. Is that what you're thinking?
Yeah.
Yeah, you could do that. It's not asking how many, so it's just yes or no, which is makes it a little bit easier. Then axis symmetry would be like if you have a pole down the center, can you rotate it onto itself before it goes all the way around? Yes, you could. And then for this, it would be a no. Like you'd have to rotate it all the way around for it to land in that same position. So this one's a no. Then number 9, sorry, it says steamboats. A paddle wheel on a steamboat is driven by a steam engine that rotates the paddles attached to the wheel to propel the boat through the water. If a paddle wheel consists 18 evenly spaced paddles, identify the order and magnitude of rotational symmetry. So imagine a steamboat has like paddles 1, 2, 3, 4, and so on. There's a total of 18 paddles. They're evenly spaced, then the order is 18. And then magnitude of rotation, take 360 divided by 18, and that comes out to 20 degrees. So every 20 degrees, it rotates into the same position. And that's just all. Let me see if, for whatever reason, if class link is up again, we'll see. Nope, no class link. I have a feeling it's going to be down for a minute. Okay, so that's just all we have planned for today. I would have you do the Schoology homework or Alex, but it's not up. If it comes up today, go ahead and like jump on and do it, but for right now you can't. So yeah, you can just get your phones, chill, vibe. Let me know if you need anything, but